Yes, good evening, everyone. Okay, Meenal, what are you asking? AC concept? Good evening, everyone. Am I audible?
Yes, sir, everything is fine.
Okay. Meenal, you were asking about the AC concept, right? Okay, so what do you want exactly in AC? AC is alternating current, yes. So what you didn't understand at that time? Characteristics of AC? What I didn't explain? There was no means depth topic of AC. It was the AC and DC, right? Conversion. So I explained that what is AC, what is DC. I show you the characteristics of AC. Hmm? I think you are asking about the characteristics. Tell me. Okay. So actually, I'm just coming to the blank page. Okay, I'm here. Actually, we have two types of currents. Alternating current, that is AC, and direct current, that is DC. Okay. So what is AC? So AC is basically we got from the source which is known as voltage source and current source. Right. Voltage source, we use this type of symbol like this in the circuit, and current source will be like this arrow. Okay, this is the which will be connected with the circuit, right? These are the two sources that we used for AC, right? For DC we use battery, means battery provides direct current, and these type of sources provide AC, okay, alternating current. And the characteristics that we see, that is the sinusoidal. I was talking about this thing. This is the sine wave. This is wave actually, okay? And the name of this wave is sine wave, right? Please hold on. right? So the name of this wave is sine wave, and sine means sinusoidal. In short, we write sine wave. Okay, it is studied in mathematics also, right? Sine, cos, right? So that is that thing only. So sine wave starts from this point, and one wave that starts from zero goes up to this. This is positive direction. This is negative direction. This is reference line. Right? Above that, it is positive. Below this is negative. So the wave goes up to positive. Okay. Again come back to zero, and again goes maximum in negative, again back to zero. So this from zero to this zero means one complete positive, one complete negative. It makes one complete cycle, one cycle, right? So this way we show in this source. Okay. So whenever we talk about the working, wherever we are using AC, so we talk about positive half cycle and negative half cycle. Okay. So we applied positive to transformer. Transformer works on AC. How? The supply which is coming to our home is AC, and transformer is providing that. Okay, high voltage is coming to this transformer, and transformer is stepping down. So step down transformer is used there, stepping down to 240 or 220 volts, right, and provide to us, right? So this is transformer. So whenever we write positive and negative, it depends upon the cycle. So alternatively, there will be positive, negative, again positive, negative, like that. So this is about alternating current, that how it works, what means during positive half cycle, what will happen. So whenever we use diode, p junction diode, so positive should be connected with p, then it will be on. If it is connected with n, it will be off, right? Clear? So this is about AC, and DC is basically the battery and characteristics. This one is the AC characteristic, and DC will have the straight line. There is no variation. If it is 5 volt, it will remain 5 volt till the end. Up to this point, it is same. It is 5. Everywhere it is 5. But here, it is this. It is maximum. Again, it is less, 0. Negative, negative, like this. Okay. So it is varying at every time. It is not same, right? So it is, if at this time it is this, this time it is this time it is maximum, this time it is less. So every time we will get a different value. But in case of DC, it is constant. Okay, it is constant. Okay, Meenal, understood what we are talking about? Meenal, got it? Shall we start this topic, new topic again? Meenal is there. Meenal, we are going to start the next topic. Okay, have you understood? After asking the question, Meena has gone somewhere. Okay, so let's start the next topic because it was actually asked by one of your classmates. So the next topic is the transistor. We have studied about semiconductor material, then we developed the PN junction. Now we have transistors. Okay, so transistor is again the basic component that we use in many of the circuits, right? And it is very important component. So these are the guidelines, common guidelines that you already see. These are the objectives that we will describe transistor and mode of operation, how does it work, what are the various characteristics and current component of transistor. We will also discuss about the current gain. Current gain depend upon the configuration that we are using which configuration. Depending upon there will be alpha, beta or gamma. Okay, so we will have configurations CE, CB and CC. So these are the content that are related to transistor, mode of operation, characteristics, current components, gain, majority current and challenges of the transistor. So Meenal, have you clicked the pic or not? Because I'm moving to the next slide. Okay. So what is basically transistor? So transistor is in PN junction. We will start with PN junction. PN junction had two regions. One was known as P region and region. These were the two terminals. Okay. So this was the PN junction diode where we use only two regions. But transistor is having three regions like this: one, two, three. If three regions are there, then we will connect three lines with every region like this. Here it was known as P region, it was N region, but here there are three regions and will be made up of the same material P, either P or N. We have only two semiconductors, either P or N. So first is known as emitter region. Second is known as base emitter, base. In short, we write B. Okay, this is base, and this is collector. So I am writing C above that. So transistor is three region device where first region is known as emitter, second region is known as base, and third one is collector. So as the name suggests, emitter means which emits. Transmitter means which transmits. Similarly, if emitter is there, what does it mean? Which emits. So what it will emit? Emit means transmit. Okay, to transmit something, to send something. Okay, so what this region will emit? So obviously we have either P or N semiconductor. So we have two options. We can use P type, then we cannot use the same material for B, so it will be N. After N, it will be again P. So we have one transistor that can be PNP. Or if we use N for emitter, then we will use P for base and again N for collector. So we have two transistors, PNP and NPN. Okay. And in this case, we have P where charge carriers are holes. We have N where charge carriers are electrons. Okay, so we have two charge carriers, and the conduction in PNP or NPN transistor is due to both holes and electrons. So if current is flowing due to both of the charge carriers, that is why the name of this transistor is known as bipolar. Bipolar junction transistor. Okay, bipolar junction transistor. In short, we write BJT. Okay. So bipolar, why it is bipolar? Because the conduction is due to holes and electrons. The conduction is possible in this type of transistor is due to holes as well as electrons both. That is why the name of this transistor is bipolar junction transistor. If we have three regions, so between emitter and base, this is junction J1 and this J. Because in PN junction diode, there was only one junction. So this is only J. But here it is J1, it is J2 because two junctions are there. One is between emitter base, second is between collector and base. Got it? So this is first, this is second. So two junctions are there. So you can see here it is EB and CB. EB means emitter base, CB means collector base. Got it? Any doubt? We will understand this symbol separately because I don't want that you should learn this thing. You should understand why it is inside or outside. I will just say that if arrow is inside, it is PNP, outside it is NPN. But I don't want that you should learn that like this. You should understand the working. Then after you will realize that why it should be outside or inside. Okay, so I'll just draw the diagram and working also. Then you will be able to understand why it is inside, why it is outside. Okay, any doubt till this point? Any doubt to anyone? No doubt. Okay, so no doubt to anyone. Okay, now we talk about the reasons that we have: emitter, base, and collector. Right. So what is in emitter? What is the role of emitter? What are the charge carriers of emitter? Okay, so we will talk about this in these three reasons. So first thing we should know what is the use of emitter. So it is emitting, as I told you. Collector means it collects, it emits, it collects, and this is base. So base is basically the mediator between this and this. So emitter means it emits the charge carrier. So if we have P and P, okay, or NPN, I am writing here. So this P is showing the emitter, this N is showing base, this is showing collector. Here N is showing E, B, and C. So in case of this emitter reason, we have P-type semiconductor. So P-type means there will be holes. So majority charge carriers will be holes in this case, that is PNP. If we talk about NPN, so this is an emitter region is made up of N-type semiconductor. So electrons will be there. So electrons are majority charge carrier in NPN, holes are majority charge carrier in PNP transistor. So that is why it is written that emit majority charge carrier electrons or holes. So because it is common for PNP, this is only emitter. We have not written it is for NPN or PNP. So for common understanding, it is written electrons or holes. So you should know which charge carrier will be there in case of PNP or NP. Understood? So we have two types of charge carriers, holes or electrons. So it depends which type of majority charge carrier will be emitted. That depends upon the type of transistor that you are using. It may be PNP or NPN. If you are using PNP, then holes will be there. This one. If you are using NPN, then electrons will be there. I hope you understand. And if it is emitting the charge carriers, then it should have the maximum number. Okay, that is why the doping means mixing of impurity that was increasing the number of charge carriers. So the doping of emitter should be highest. It should be highest. If doping is less, number of charge carriers will be less. If number of charge carriers are less at emitter region, then how it will emit the maximum number? If we want a high current, then maximum charge carrier should be transmitted or emitted, but it should have at already less number. Then how it will emit? So it should be highest. The doping should be highest of emitter. Clear? Now I come to the collector first. Collector means which collects what it will collect. It will collect whatever is emitted by emitter. Okay, it may be electrons or holes. So all will be collected at collector region. Okay, so the doping of collector should be less than emitter. So it is moderately doped. Moderate means it should be middle level. It should be at middle level. Means it should not be highest. It should not be least. It should be at mid level. Okay, moderately doped. It should not be highest. Highest will be of emitter. Okay, so what it will do, it will collect the majority charge carriers that are coming from emitter. So obviously it will be either electrons or holes. Clear? Now I come to base. Third point will be discussed after base. Okay, the third one is base. Highest doping of emitter, moderate of collector. It should be lightly, means least. It should be least. Okay, and what is the use of base? That is to stop the majority charge carrier which are coming from emitter and going towards collector. The working is like that. This is emitter, this is base, this is collector. Whichever is coming from there, it will be stopped by base first. Whatever is remaining will be transmitted or emitted to collector. Okay, so if 100 charge carriers are coming from emitter and 20 are stopped by base, then 80 will be reaching at collector, like that. Okay, because why it is only 20? It can stop 50, it can stop 60, but we have already taken lightly doped base season. The doping is very less. If doping or base is less, then because suppose holes are coming, electrons are here, right? So holes and electrons will be recombined. So if we are using 60 electrons, then 60 holes of out of 100 will be recombined. Only 40 will be remaining. But we want the maximum number at collector. It can be possible if base is lightly doped. That is why, due to light doping, it can recombine with 20 electrons only, right? Remaining will be 80. So this is just an example, okay, to make you understand that what is happening there. So that is why it is slightly doped, and it is the use of this is to stop the magnetic charge carrier which is reaching to the collector. Okay. Now we come to the area. The collector wants to collect the maximum. Okay. So area of collector is highest. Base is the least. That means the area of emitter is less than collector but greater than base. So it is at middle level again. So we have three things: doping, second is the area, okay, and what is the use, okay. So first is, if we talk about the doping, emitter has the highest, base has the least. So collector will be moderate, and in case of area, collector has highest and base has least. So emitter is having middle or the area less than collector and greater than base. Okay. The working, the what is the role of emitter based collector, you have understood. Emitter role is to emit the charge carriers, majority charge carriers. Collector is to collect the charge carriers, and base is to stop the charge carriers. So we are having less, then it means maximum number of charge carriers will be transferred to collector after recombination. So whatever the holes and electrons are recombined, remaining will be transferred to collector, and they will be flowing the collector current. Okay. If emitter majority charge carriers are moving, then I will be flowing. If if base, if here it is moving, then base will be, current will be flowing, and after reaching at collector, then IC will be flowing. So after movement of charge carriers, the current IE, IB or IC will be flowing there. So this is the working of the reasons. Now the application of transistor. So before that, I will explain this one. Okay. Then after we will come to that point. So this diagram will also show you that why the arrow of transistor is, I am just drawing here again. We will not go back to there. Why the arrow is inside or outside, like this. Okay. We will write the name of transistor later on. Here, we will write the name here. After understanding the working, you will tell me that which one is this. Okay. So here we have used NPN transistor. NPN means the charge carriers will be electrons because it is N. This is P, then there will be holes. This is again N, there will be electrons. Okay. So this is all about the semiconductor that we have already studied. Now we have to use this transistor in different mode. Now we will come to this. What is this? Because it will be used in this diagram. So what is this? We have two junctions. This is J1, this is J2. Okay. So we are actually making junctions forward bias or reverse bias. Here it is, right? FB and RB. So we have two options. So I can make junction J1 forward bias, J2 also forward bias. I can make J1 reverse bias, J2 reverse bias. I can make junction J1 forward bias, second reverse bias, first reverse bias, second forward bias. Okay, so we have four options. Okay, so these are four combinations in which We are making junction J1 forward bias, J2 again forward bias, J1 reverse bias, J2 again reverse bias, both forward, both reverse. First forward, second reverse, first reverse, second forward. So these are the maximum possibility for two junctions, two variables. Okay, there may not be any fifth option. There will be only four because it can be calculated using 2 raised to power n. Okay, it is in digital electronics. So n means variable, one variable, two variables. So if we put two, so it will be four. So four combinations are maximum possible. Okay. So if we are making any junction forward bias, reverse bias, so there will be respective uses also. Which type of mode it is having, right? So I will come to this first. First, we are making junction J1 forward bias and second reverse bias. Okay, forward bias, reverse bias. Which one? This one forward bias, this one reverse bias. Okay. So similarly, again reverse forward. So which mode it is? It is known as active mode. So if I ask you that in active mode, which junction will be forward or reverse? So answer is junction J1 should be forward, second should be reverse. Okay. And same, it is used for what? It is used for amplification. So if we want to make amplifier, so what is the requirement? You should use active mode. So if I say active mode, it is understood that junction J1 should be forward, J2 should be reverse bias. How we will make forward reverse, we will see in this diagram. Okay, that is why I came back to this topic. Now second is both forward bias. We have make both forward, J1 forward, J2 forward. So what is this? The mode is known as saturation mode. So if I tell you that in saturation mode which junction will be forward bias or reverse bias, so your answer should be both will be forward biased, both, right? And this situation, this case will be used for switching. Switching means switch on or off. So if both are forward bias, forward bias means the movement of charge carrier is free, is very easy. Then if charge carriers are moving very easy, it means it is switch on condition, so it will be switch on. And if we have made both reverse bias means no possibility of moving the charge carrier like this. So both are reverse bias. So if charge carriers are not moving, then what will happen? It will be in off condition. So it is switch off. And this mode is known as cut off mode. Okay. So basically we use three modes. Okay. Both forward, both reverse, first forward, second reverse. So both forward, switch on, both reverse, switch off. First forward, second reverse is for amplifier. Okay, so this, and you should remember the name of mode. Both, if it is on, it is known as saturation. Off, it is known as cutoff, and in amplifier, that is active mode. If we want to use anything, it should be active. So you can remember like this. The active mode is used for amplifier. And if we use this case, first, reverse, second, then it will be attenuator. Attenuator means which attenuates. Attenuates means which cuts. Okay. If we want to remove some part, then this will be attenuator. Right? If we want to reduce the value, then it is attenuator. So basically we use these three ones. That is why I am telling this in the end. So I hope you understood this thing. Understood or not? Okay. Now we come to this diagram. Right? So as I told you that we want to use transistor. So we want actually For switching, we have PN junction, right? But if we don't have PN junction and we want a switch, then we have option to make transistor as a switch. But basic use of transistor is for amplifier. Okay, and for amplifier we should use active mode. Okay, we will not directly purchase give me transistor for switching, right? We will not. But if we don't have option, then we have the process to make it as switch. So we will just forward bias both for switch on, reverse, then switch off. So this is the last case that we can use. But basic use of transistor is for amplification. So if we are talking about working of transistor, so it is nothing but for amplifier. And for amplifier, it should be active mode. And for active mode, it should be forward bias, it should be reverse. First forward, second reverse, that's all. And how we can make NPN transistor in forward and reverse. So first we have N type. And if N type is having electrons, right? Right? So what should be there? N should be connected with the negative. And should be connected with the negative. So you can see here, battery, this negative terminal is connected with N type. And for this collector is of N type, and this N type is connected with the positive terminal of the battery. This is positive, so it is making reverse bias, it is making forward bias. So we have made it in active mode. Okay, so this is very easy. So this battery is connected between, this is base, this is emitter, this is collector terminal. So we have just connected between emitter and base, between collector and base. And this common line is grounded. This is ground. Now how it is working? So this negative terminal of the battery, and these are electrons. So what will happen? Negative, negative, repulsion. So these electrons will be repelled towards this. It will be repelled. Okay, and if it is repelling, it means holes are moving in this direction, then current will be coming outside. So this current IE will be outside from this emitter, right? Clear? And if this IE is here, in this case, these are electrons, this is positive. So what will happen? Electrons will be attracted. If electrons are coming in this direction, then current will be in this. So IC will be inside. IC will be this direction. And if we talk about this base current, this is positive, this is of P type. So this positive will repel holes in this direction, like this, forces like this. So in whole direction, the current will be in same direction. So if it is moving in this, so IB will be, I'm just removing something. So IB will be in this direction. So if I draw this like this, IE is this, IC is this, and IB is this. This is node, for example. So we have studied KCL and KVL. So what will be the equation? At this node, all incoming current will be equal to outgoing current. So this current is incoming, this current is also incoming, this current is outgoing. So outgoing current will be equal to incoming current. Incoming current are two, IB and IC. So both will be added. So this is the current equation of transistor. It doesn't matter that it is whether it is NPN or PNP. If it is PNP, then direction will be changed only, like this. IE will be inside, IC will be outside, IV will also be right. So again, if you apply KCL, the current equation will be same. IE will be equal to IB plus right. So all will be opposite. Whatever is moving in this direction, in this case, it will be in that direction. That's all. So now you tell me that IE is coming outside this. So which transistor is NPN? First or second? Now we will give the name to these symbols. Tell me which one is transistor 1 or transistor 2 is NPN. See this current first because this is emitter, this is collector, this is base. This is emitter, this is base, this is collector. Yes, who will tell me which one is NPN or PNP? This is 1, this is 2. So number 1 is NPN or number 2 is NPN? If you don't give the name, I will understand that you are not listening. Because IE is outside, so which current? Here it is going outside, so this is NPN and opposite will be PN, right? So we can give the name. I actually wanted that you should not remember, you should understand why it is inside, why it is outside. So arrow wherever if I don't write B, C or E here, even you should know which one is emitter terminal. So arrow will be drawn at emitter terminal only. It will not be collector or any, right? So if it is once we consider, suppose this, if it is emitter, then mid one will always be base and remaining will be collector, right? So total current IT is majority current as well as minority. So as we have studied in P type and N type, in P type holes are majority while electrons are minority. In N electrons are majority, holes are minority. So they will be both majority and minority current. So total current will be the addition of both majority current as well as minority. So here it is majority current is due to electrons, so it is IE. Minority due to holes, this is IC. For PNP, IT will be IH plus IE because holes will be majority charge carrier in PNP transistor. This is for PNP. I hope you understood this thing. We should move forward. Okay. Now we come to the configuration. So what is configuration? So what we studied? We studied that this is transistor, This is transistor, for example. This is emitter. This is base. This is collector. And in any network, network means circuit. If we have any circuit, then two terminals are required for input and two required for output. Four terminals are required. Four terminals. But we have only three: emitter, base, and collector. Three terminals are there. So what we can do? We cannot add something because it is by manufacturing there are only three terminals. So what we can do? So to make it four terminal, then one terminal should be common. We should use one terminal, any, whether it is emitter, base, or collector. It can be used as common terminal. So the terminal which we are using as common will be known as that type of configuration. So in this case, we are using base as common. So this configuration will be known as common base. Here we are using emitter as common. It will be common emitter configuration. Here it will be collector. It will be known as common collector. So how we will make it common? So if we connect this as this, so now input will be applied at here. This is common, this is grounded, and output will be taken between this. So whenever we apply something, it will be main and ground. If we take output, it will be main and ground. So this ground is negative or grounded line, and we are applying input with respect to this. We are taking output with respect to this. So this emitter terminal is common. So this is known as CE configuration. This is common emitter configuration. If we have common collector, so we will just invert. Invert means it will be same, but arrow will show which terminal it is. So this is emitter now. Collector has come here. So what we will do, we will just make it common like this. This, this is input, this is output. So this is known as common collector configuration. And last one is common base. Now in case of base, so two things you should remember. Base will always be input terminal if it is not common. Until unless base is common, it will be used as input terminal, always input. And collector will be used as output terminal until unless it is common. So in this case, you can see that collect neither base nor collector is common. There was emitter. That is why emitter, base is input terminal and collector is output terminal. Both are both are fulfilled. In this case, base, because collector is common, so this is not fulfilled here. But base, this one is fulfilled. So base is used as input. Collector is here, so output will be remaining third one, that is emitter. So emitter is the output terminal in this case. Now we are using base as common. So base will be like this, like this, like this. Now can anyone tell me that in case of common base, which one will be input terminal, which one will be output? So see this, out of these two conditions, you have to check this. So if we have to fulfill both, it is not required. One should be at least fulfilled. Along with your attendance, you should give the answer of the question too. It is more important. So in this case, base is common, base is common, this is fixed, but it will be emitter or base, we don't know which one is it, is emitter or base, we don't know. So we will check this. Base condition is not fulfilled, but collector can be fulfilled. So collector is always output. So it will be collector. This is base, then remaining will be emitter. So emitter will be input terminal, collector will be output terminal, right? So input will be here, output will be here. Just a minute. Any doubt to anyone? Understood? So I hope we will discuss this in next lecture because it will take time and the understanding is very important. So in all these configuration, the thing that is very important is this. If you remember this thing, then which will be input terminal, which will be output terminal, it will not be wrong. It will be, if it is correct, then after the your answer will be correct. Otherwise, everything will be wrong. So you remember these two things: base input, collector output. So if base is common, then collector condition will be fulfilled. If collector is common, then base will be fulfilled. Means one condition will be fulfilled in any of the cases, right? And in case of common emitter, both are fulfilled because emitter is common, neither base nor collector, right? So both will be fulfilled like this. Base is input, collector is output. So both are fulfilled. But in another two cases, one will be at least fulfilled. So you remember this thing: base input, collector output. So I hope you understood all the topics that we covered today. We will discuss all the configuration in detail because there are certain circuits and the terms are there. So understanding the terms is more important. Why it is VEB, why it is VBB, right? So we have to understand this thing very carefully. That is why I am not teaching today. We will discuss next session. Now tell me any doubt, if any. Anyone? Everything is clear to everyone? Okay. Thank you. Thank you. Okay, so we will meet in the next session. If you have any doubt, you can ask me in next session also. Right. So thank you so much. Happy learning. Thank you. Take care. Bye bye. You can leave and join the next session.